All right, we're going to talk about general equations, kind of solving general equations, especially of this format. Okay. All right, this format. Boom. Ax plus b equals cx plus d. If we got x's variables on each side of the equation and numbers on each side of the equation, we gotta have a strategy to solve that equation. And remember, solve means tell me what x is equal to. Wow, I'm not being cooperative today. Solve means tell me that x is equal to some number, and it has to be 1x is equal to that number. So we're going to solve equations, and we're going to solve including parentheses. Remember, solving equations means that x is equal to whatever variable, and we've got to find that that equation, or sorry, that solution, x equals whatever, it makes the equation a true statement. So let's take a look at some equations, or I guess, sorry, the procedure. It looks like a lot of stuff. But number one, we're going to take a look at if we've got some complicated stuff like parentheses. We got to think about clearing out parentheses. In fact, don't think about it. You have to do it. So we got to clear the parentheses so we have just terms. And so we've got to clear the parentheses. If we've got parentheses in our equation, we've got to multiply things to get rid of the parentheses to get just terms. Terms are separated by addition and subtraction. When we have just terms, then we combine like terms. We'll talk about what those are in just a second. So we get clear parentheses and then combine like terms. And then essentially after that, we're going to have something like ax plus b equals cx plus d. Some variables on each side, one or both sides, and some numbers on one or both sides. And then what do we have to do? We've got a number one, use the addition or subtraction property of equality to move the numbers to one side. Numbers to one side. And after that, step number three, use the addition or subtraction property of equality to collect the constants on the others. Numbers to one side, variables to the other. Variables to the other side. And then step four is if we have some number that's in front of the x, some coefficient that's in front of the x, we've got to divide by that coefficient on both sides of the equation. Use the multiplication and division property of equality to make the coefficient, the number that's in front of that variable, into a 1. So if we've got something like 5x equals 10, we don't want to know what 5x is. We want to know what x is, or what 1x is. So we've got to divide by 5. Divide by 5. That would be the example in the red. Use the multiplication or division property of equality. Treat both sides equally, divide by 5 to get just 1x over here on the left. X equals 2. And then the last one is, check your answer. And keep in mind, the goal is always to get x equals some number. And not only x, but 1x equal to some number. Right here is that where we get that in red. And step number 4 is where we get the 1x, dividing by the coefficient if it's not 1. And it really doesn't matter. The last bullet is it really doesn't matter where the variable goes, because if we're going to have some variables and some numbers and variables on both sides of the equation, don't be so concerned that I've got to put my x on the left, or I've got to put my x on the right, or my variable has to go this side or that side. It doesn't really matter. As long as the variables are on one side and the numbers on the other, you're all set to go. So step 2 and step 3, and I really step 2 and step 3, let's see, I describe that as the middle school dance, because I remember when I was in middle school, we'd come into the dance and we'd say, all right, I'm a guy. Okay, where are the guys going to go? Guys are over in that corner. Okay, guys, I'm going to go with the guys. Girls come into the building and they say, oh, where are the guys going? Where are the girls going? The girls are over there. I'm going to go with the girls. So keep in mind that that's the analogy that I use, kind of the middle school dance, where the guys go to one side of the dance and the girls go to the other side of the dance. Well, in this situation, if we apply that to these equations, the variables go to one side of the equation and the numbers go to the other. So there's the middle school dance analogy that I try to use. All right, so step number 1 back here was clearing parentheses and combining like terms. So clearing parentheses just really means taking this number that's outside the parentheses and multiplying by everything that's inside the parentheses. So you take the 5 times the 3x, and sometimes if there's no sign that's assigned to it, if there's no sign present, we have to assume there's a plus sign out there. If there's no number out here, we have to assume that there's a 1 out here in front of the parentheses. A couple of things we have to assume. So now we take, if we're going to clear parentheses, we take this 5, multiply by every term that's inside. 5 times 3x is, well, we'll take the long way. 5 times 3x is our first term, and we could, I guess, put the plus out here. The second term would be positive times positive is positive. 5 times 1 is 5 times 1. What we're doing is just showing that we've got everything. We've got that 5 multiplied by every term that's inside the parentheses. 5 times 3x, and then 5 times 1. Pay attention to signs. 5 times 3x becomes 15x. Plus sign drops down. 5 times 1 is just 5. Same idea holds true here. I got a plus, I got a 5 unwritten plus sign out there. 5 times 3x, 5 times negative 1. 5 times 3x is still 15x. We don't have to put the plus sign out here because it's a leading term. We assume it's a plus sign, so we don't have to write it. Positive times negative is a negative. 5 times 1 is 5. Done. And all we're doing is distributing this 5 across the parentheses, multiplying that 5 that's out here with the sign included. Pay attention to the sign. And then multiply this 5 by everything that's in here. Right here now, the only thing that's different here is a negative 3x here. But we still have that unwritten plus sign out here. So, hang on, I'm going to change it to a different color. 5 times negative 3x is positive times negative, negative. 5 times 3, 15. X times 1, x. Second term is positive times positive, positive. 5 times 1, 5. Done. And we've distributed across the parentheses, and now we've got terms. Same thing holds true over here. Last one, negative 5 times 3x, negative times positive, negative. 5 times 3, 15. X. Negative times positive, negative. 5 times 1, 5. Done. And for all these examples, I've cleared the parentheses by distributing that term that's outside the parentheses multiplied to everything inside the parentheses. And that's all we do when we clear parentheses. Pay attention to signs, and then multiply numbers, and then multiply variables. All right, last thing. Yes. All right. So last thing before we end this video is talking about a like term. What is a like term? Because if we go back to parentheses, here's our steps. Clear parentheses, combine like terms. All right, what's a like term? Like terms. There we go. What's a like term? Like terms are like if they have the same variables and the same powers. So like terms have exactly the same variables to exactly the same powers. So here are a couple of examples of like terms. Like terms, b to the first, b to the first. PQ, PQ. W, W. Okay, these are all like terms, pairs of like terms. These are all like terms and can be combined. If we were adding these up, it would be 3b plus 5b would be 8b. Over here, we got unlike terms. We got those unlike terms. Unlike terms because C and D are different, not the same variable. P and Q, different, not the same variable. W and no variable, not the same variable, not like terms, cannot be combined. None of these pairs can be combined because they are unlike terms. So down here, 3x and 5x, yes, like terms. Excuse me. Number 2, 3x and 3. Well, the 3's are the same, but you know what? We don't care about the 3's, we care about the x's. Unlike terms, right down here. Because the like terms have to have the same variable to the same power. These don't have the same variable. 17ab and ab, yes, like terms because ab is exactly the same. This is an unwritten 1, keep in mind. So if we're adding these up, 17ab plus ab would be 17 plus 1 would be 18ab because we're adding up the coefficients. Unwritten coefficient there. 17x and 17xc. 17 is the same, but we don't really care about that. The terms have to have exactly the same variable to exactly the same power. This has a c. This doesn't have a c. Not like terms. Unlike terms. And there's just some terminology. for equations.